Hi, this is Pradeep Sharma and today we'll see 4 concepts of data mining using SAS Enterprise Miner. So let's get started. To save the time, I have already executed the flow diagram and I'll be going through the results one by one. The first concept is imputation. Imputation is a way of replacing missing data from a dataset. Missing values make it difficult for analysts to perform data analysis. 3 types of problems are usually associated with missing values are as follows. Number 1, loss of efficiency. Number 2, complications in handling and analyzing the data. Bias resulting from differences between missing and complete data. The simplest way of dealing with the missing values is to discard the examples that contain the missing values. The other way of dealing with missing values are mean and count. If you go to the results of the impute block, you can see that we have 4 variables with the missing data. We have 4 variables, that is balance, duration, housing and loan. The impute method for housing and loan is count, and balance and duration is mean. The mean method is for numerical variables. We compute the mean of entire variable and assign this mean value in place of the missing data. The count method is for the nominal variables. In this method, we take the count of the entire variable and the one with the highest count is assigned to the missing value. As you can see from the results, we have 31 missing values in the balance variable, 11722 from the duration, which has already been filled with the mean method, and in the housing variable we had 19 values missing, that was computed by using count method and been fulfilled. The next topic is feature selection. In machine learning and statistics, feature selection, also known as variable selection, attribute selection, or variable subset selection. It is the process of selecting a subset of relevant features for use in the model construction. Feature selection techniques are used for 3 reasons. Number 1, simplification of models to make them easier to interpret by researchers. Number 2, shorter training times. Number 3, enhanced generalization by reduction of overfitting. If we take the example of decision tree, if the decision tree is complicated with multiple leaf nodes, there is a chance of overfitting. In order to avoid this, feature selection provides a way to select the most relevant variables for the decision making purpose. Let's have a look at decision tree. This is a decision tree. As you can see, it is a bit complicated, and we'll see later how we can prune this tree. Let's see the output of the feature selection block. We see that the duration, outcome and month variables were most relevant, and hence they were the 3 variables selected for the modeling processes. The R-square value for duration is 15%, for the outcome it is say 87%, and for the month is 36%. These 3 variables will be used because we already set the threshold value to 5%. So any variable with the R-square value greater than it will be used for the modeling, and rest of the variables will be discarded. In feature selection, we briefly talked about pruning of a decision tree. It's a way to simplify the decision tree model either by imputation or feature selection. So pruning of the decision tree involves getting the relevant data or relevant attributes or variables in the modeling processes. I stress on the word relevant because we want to avoid overfitting by choosing those variables which provide a significant value to the decision making. Let us now have a look at this process by providing different data to the decision tree model. In the first path, you can see that we are providing raw data to the decision tree model, and in the second path, we are providing feature selection process, and then the decision tree will be making, and then we are doing the model comparison. First, we'll have a look at the results of a decision tree without feature selection. As you can see that it is a very complicated tree, and the leaf nodes may cause overfitting, and it contains all the variables, so that makes the tree complicated. Now we have the results of the decision tree with the variable selection. As you can see, it is a simplified decision tree with the only relevant variables, or the variables which have been selected, which have been qualified in the feature selection process. So as you can see that there are less chances of overfitting, and a tree is simplified. The last topic which I am going to cover is confusion matrix. Confusion matrix is a clean and unambiguous way to present the prediction results. For a binary classification problem, the table has two rows and two columns. Across the top of the observed class labels and down the side are the predicted class labels. Each cell contains the number of predictions made by the classifier that fall into the cell. There are four important things associated with the confusion matrix. Number one is true positives. These are the cases in which we predicted yes and the actual result is also yes. True negatives, which we predicted no and the actual result is also no. False positives are the cases in which we predict yes but the actual result is no. And the last is false negative, in which we predict as a no but the actual result is yes. Last but not the least, let's have a look at the output of the confusion matrix. These are the false negatives, true negatives, false positives and true positives of the variables which we have selected so far. So we have 1125 false negatives for a target variable and so on. Thanks for watching this video and have a nice